Hey everyone, welcome to today's video. We are going to start learning about Unit 2 from today, and Unit 2 talks about periodic table of elements. So today we are just going to understand about periodic table and reading it. So today's class lesson is to navigate the periodic table of elements. So the objectives for today's class is you should be able to classify components of a periodic table. So the periodic table has periods, groups, metal, metalloid, non-metal, and some transition metals. So by the end of today's class, you'll be able to classify these components in the periodic table. And the second one is you can identify representative elements as A groups. So there are two groups, one is A group and then B group. So apart from the other groupings, you'll be able to classify A and B groups. And then identify alkali metals, alkaline earth metals, and noble gases based on the location on periodic table. So this is what today's objective is. You have to pause the video and start writing it in the area that you have to mention the objectives. And starting with the essential vocabularies for this lesson, the first one is element. So the element is the building block of matter which cannot be broken down by any physical or chemical means. So any small box that you see here in the periodic table is an element. So hydrogen is an element, lithium is an element. So anything that you see in the periodic table is an element. And what makes the definition of the element is anything that you can see in this periodic table cannot be broken down. And then periods. So if you see in the periodic table, it would be organized in such a way that it has 7 rows on it. It has 7 rows on it. So the rows on periodic table numbered 1 to 7. Numbered 1 to 7 is called as periods. So this would be period 1, the one which is pink colored is period 1, the orange is period 2, and this makes period 3, 4, 5, 6, and then will be 7. So there are 7 periods in periodic table. Then coming to groups, they are the columns. Every column is classified as columns and they are numbered from 1 to 18. If you observe in the periodic table, it will be having 18 columns and each column is mentioned as different groups. And these groups, they are also known as families. And apart from these 18 groups, there are two major groups which is called as group A and group B. If you see on top of the periodic table, it would be mentioned as 1A and 1B. So group A are the representative elements which starts from group 1, 2 and then it goes to 13. So A group includes group 1 and 2, 13 to 18 which are called as the representative elements and B group consists of transition elements. So let's have a look at it. So here if you see these are the periods, as I say this way it is the periods, second period, third, fourth, like that. And when talking about the groups, this would be group 1, group 2 and 3, 4. So these numbers on top of it, the numeric numbers represents the group it is. So this one is group 13 and this would be group 18. Similarly, when the groups are categorized as A and B, if you see this is mentioned as 1A and this is actually 3B. So 1A, 2A and then here goes 3A. So it continues from 3A to 8A, but here it starts as 3B, 4B and so on. So these, as I said, 1, 2 And then 13 through 18 are called group A, the representative elements. And starting from here are group B, that are called as transition elements. So, how do we group elements? You can see there are different letters based on certain numbers, which is atomic number that we have learned, but this is being organized based on certain aspect, that is what is increasing atomic number. So you all know the elements are grouped based on its increasing atomic number, and it can be categorized based on three major aspects: by element composition, by state, and by family. So let's now see how is it classified based on element composition. So based on elements, the groups are categorized into three major types. So the first one is called as the metals. Metals are good conductors of heat and electricity. So if you see some shiny material that is running inside an electric wire, that is a metal because it is a good conductor of heat and electricity. And they can shine, which is called as high luster, and these metals are ductile and malleable. It means that they can be made into something thread like structures so that we can do something with it. Like if you see these jewelries and ornaments, they're all made up of metals because it is ductile and malleable. It can be molded. And the best example for that would be copper and gold. And you can have a practice, pause the video and try to locate where copper and gold are in the periodic table. So next one is non-metals. In contrast with metals, non-metals are poor conductors of heat and electricity, and they'll be dull and brittle. They do not conduct electricity, they'll be dull. And the examples include carbon, phosphorus, and much more, which you will learn at the end of today's class. The third category is metalloids, and identify in the periodic table that has been given to you with the staircase pattern, and these metalloids are generally placed or located on the staircase of the periodic table. Generally, they have properties similar to metals and non-metals. So they stay somewhere in between metals and non-metals, and they are medium conductors of electricity, and they are also known as semiconductors. So if you see in this picture, it is a metalloid. The examples of metalloids includes silicon, aluminum, and you will explore much more. So how do we group elements based on its state, which is the second type? So you know there are three states which can be present: solid, liquid, and gas. So there are three states. If you observe here, it has solid, liquid, and gas. So in the periodic table, there are only two elements, which is 35. And if you check what 35 is, that is bromine, and Hg with atomic number 80, which is mercury. Only those two will be liquids, and those which are painted in this yellow color, they are all gases, and it includes hydrogen. So hydrogen and these are gases. Alright, just two will be liquids and the rest are solids. Now take some time, pause the video and take this time to do some coloring. So I can give you how to color. First, make a key. Make a key like for solids, I'm going to color this. For liquids, this. For gas, this. As well as you are going to differentiate them as metals, metalloids, and non-metals. So you are going to color to identify if something is metal, non-metal, or metalloids, as well as if it is solid, gas, or liquid. So keep it neat. You can use your pencil sharpener, pause the video, and take this time to paint it. If you look for the key, see, I can just give you an example where you can use like blue for liquid and red for gas. as an outline, and solid you can just leave it as without an outline because there are so many solids in there. And then for non-metals I have given orange, for metals green, and for metalloids yellow. So this is what my key is. Similarly, you can make your own key to identify these 6 categories and you can use it. So state of matter, only 2 liquids, gases, and the remaining are solids. And then coming to metals, metalloids, and non-metals based on its composition, draw this stair-step pattern. So you should be able to know what stair-step pattern is. Try to identify where it is so that it will be easy for you. So anything in the stair-step would be metalloids. Everything to the right of metalloids and hydrogen will be non-metals, and everything to the left of stair steps will be metals. So this is how you can identify elements on the periodic table. So this is what I have done with coloring. So I have been mentioning something about the staircase. So you have to be able to identify this staircase. If you see, so anything that is lying between this staircase are metalloids, right? In within this staircase, metalloids, right to it are non-metals, and left to the staircase are metals. So here hydrogen will be included as non-metals. And coming to gases, liquids, and solids, just these two will be liquids, and the one with the red outline are gases, and the rest are solids. Just take enough time to do your coloring neatly. So the third category by which it is grouped are by family. We'll see what families are and what are different families. So elements are sorted into groups or families based on their chemical properties. Based on their chemical properties. The least reactive elements are on the far right side, and the most reactive elements are on the far left side, which is group 1. So in the coming classes, we'll be studying what most reactive means. So the first is group 1. So here group 1, except for hydrogen, it starts with lithium, sodium, potassium, rubidium, cesium, and francium. These are all included in group 1, which is called as alkali metals, and they are able, or they are the one which react with water to form hydroxide ions, so creating a basic solution. You would have heard what basic solution is, but we'll deal with what basic in our coming chapters. So coming to the properties of these alkali metals, they are very reactive, donate electrons easily, they are soft, silver in color, they have low boiling as well as melting point, and they are malleable and sometimes soft enough to be cut with a knife. It is not always, sometimes they are soft enough to be cut with a knife. So this is group 1. And then next comes group 2, which is alkaline earth metals. That includes beryllium, magnesium, calcium, strontium, barium, and radium. So this is group 2, which is called as alkaline earth metals. And their properties includes more metallic in character than group 1. They have 2 valence electrons, and again we'll study what valence electrons in the coming lessons. Having valence electrons means they can easily lose those electrons. They are the second most reactive group on the periodic table. And group 3 includes transition metals. So this group 3 to 12 includes this, as well as you can see something in the bottom of the periodic table, 2 rows. Everything are included in group transition metals, and their properties are they form alloys easily, they have a very high melting point, and they have more than one valence electrons. For the rest of the